Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and this is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, what are we going to be talking about today?
Hi Michael, stored procedures, functions, triggers, what else?
Yeah, so this is the age-old debate of server-side, Postgres-side logic in stored procedures.
Well, database side, we can
Yeah.
mention other databases as well.
Yeah, in
Because
fact, I think it's a
This is very old topic because I remember in 2002 I was working with Oracle and SQL Server, and we had a lot of logic inside PLSQL or TSQL code.
Yeah, that even might be a great place to start with this topic, because I think my experience with those platforms as well was people used stored procedures a lot more in SQL Server and Oracle than I've seen them doing in Postgres. My experiences varied, and I think maybe that was larger companies, and my experience more recently has been with smaller companies, so maybe that's a difference. But I definitely saw it a lot more often in the SQL Server and Oracle worlds.
Right. So this is very old debatable topic, similar to ORMs, and there are many people on both sides who big fans of stored procedures, and this love to stored procedures can be very acute. Like it's like, wow, it's so convenient and so on. But at the same time, much more people say they have problems. When I say stored procedures, of course, in Postgres terminology, I involve functions as well, because procedure word appeared only a couple of years ago when it was added, and in Postgres 12, I think. I remember
11, yeah.
Maybe 11. I remember my Microsoft SQL Server guys laughed at me saying, "Oh, only now, finally you have transaction control." Okay, it was it was friendly laughing, fortunately. But in commercial relational databases, it was considered normal to write a lot of code on server side, and if you take any bank software, you will find a lot of such code. But maybe banks are not a good example, because we know, especially in the US, they are so outdated and actually I observe them as a user, right? And they have issues with software, definitely. And I considered usually in Russia, banking is very well. It's very well, very good applications and so on. But since I'm on the opposite side of Earth, I saw recently. I'm already not using them, but last several years I saw their downsides as well. They still have nightly updates. This approach is still there. I mean the regular approach when you have a lot of server-side code, but it's quite heavy, so it needs to be executed only once per day. So you have some window and so on. It's like you try to log in at your daytime in the US, but you cannot, because you need to wait a couple of hours. It's because it's night there.
Yeah.
So it's a sign that software is not modern. Modern software should not do this. It should be always available. And of course, if you have a lot of code on server side, big question when it will be a bottleneck. Right. This is one of the criticism aspects. But before we discuss some details, again, I think much more people prefer to avoid stored procedures. I just observe it much more. I have experience of discussions like we have today, and usually reaction from audience is like a few people really support, but a lot of people discuss downsides and saying we should try to avoid it. And that's why I say I'm not normal. I'm a big fan of stored procedures, but I know their downsides, functions, procedures, triggers. I know their downsides, but I'm huge fan. I can explain why, but I consider myself as not normal. Normal is to try to avoid them. This is our normal, from my understanding, because I see much more people try to avoid. What's your observation?
I'm similar, but with a slight caveat that I don't use them myself, and we don't use them in a very small database application. I would say that it would be really interesting to hear what you would advise others to do. So whilst you're a fan yourself, if a team came to you and they have a team of maybe 20 Rails developers, and there's a couple of them that have got some Postgres expertise, but they maybe they don't have a huge application, but it's meaningful. Maybe millions of transactions. So it's meaningful, but not GitLab scale, say. What would your advice be to them? I would be surprised
GitLab,
if you would advise
GitLab,
them.
by the way, almost doesn't use it.
Well,
Almost.
yeah, I'm probably skipping ahead mentioning them, so that's good. But what would your recommendation be to others versus like what your opinion is for yourself?
Well, my recommendation is it's like let me like I have very interesting experience. I wrote a lot of code in PLP SQL, in some code in PL Python, some code in other languages, and sometimes a little bit C. But first of all, we should say Postgres is very extendable. This is one of the key places where you can extend Postgres. You can write a lot of code, and you can, for example, you can define some new aggregate function. You just need to write some function according to some rules, and then say, okay, my operator, my aggregate function will be supported by this, and so you can select your aggregate function, then group by, and so on. This is very, very good thing. You can define your operator supported by some function. It's also like I would like there's good term server side Postgres coding or programming, server side programming, in terms of Postgres side programming, right? It's not only procedures, functions, also triggers, also operators. You also can define your index type, data type, many things. But when first thing when we start, I think, very carefully think about opportunity to write to use this approach is our work with data. How strict we should be in terms of data. How we want clean data. It should be and it should be clean, and it should be how this word, I always forget this word. Correct relationships. Data is
Consistent.
Consistent, exactly. So data should be consistent. We should not have dirty data in most cases. Sometimes it's okay, but in many cases, yes. Like for example, some user data and so on. And in this case, we define some structure. We define some constraints, and there is no other way to follow constraints in 100% of cases, except to having them inside database. Because if you implement your constraint logic inside your application code, there is no guarantee that tomorrow you decide to write, or your management decide to write another application, or to work directly. I mean, user working directly with data and breaking your constraints because nobody checked them. So the only way to have good constraints is to have triggers. Well, something we can define using schema, like data type or length of text field or something. This is easy. Then you can define check constraints, but some complex logic can be defined only using triggers, and this is already server-side programming, right? Postgres-side programming. And it's inevitable if you want 100% guarantee, like warranty. Someone can guarantee that data is clean. It should be done in Postgres, on database side, right?
Okay, yeah, I like that, and I've already realized that I think my opinion is a bit of both. Like I don't see myself as one way or the other. I'm a big fan of database triggers as well, but most of the teams that I see and work with would be slowed down by development speed wise. I'm not talking about database performance, but speed of development wise.
Okay, good. Different aspect. When I discovered PostgREST, which is now very popular thanks to Supabase, for example, right? Definitely. I mean, maybe some people don't realize that they use it, but they use it, definitely. Much more users. But at that time when I worked with it, quite long ago already, maybe like 5-6 years ago, I in a couple of projects I replaced whole team myself. Like Ruby developers, 3 of developers was writing some code for some startup. Management was not satisfied. I said we don't need this bunch of Ruby, a lot of Ruby code to support some API development. We just define some views in Postgres, and that's it. But some code was immediately implemented in form of functions using PL/PGSQL. Sometimes regular SQL because you can write function using regular SQL. People underestimate this, but this is convenient sometimes. And views and some logic and everything and I felt like I'm spending like 10x less time than they spent. It's not a joke. It's really so it's so easy.
Yeah.
You just install Postgres. You need to know how to cook it in terms of authentication, some things. But once you understood it, it's like with any framework. You need to learn it, of course, right? But once you understood it, everything is inside Postgres. You define functions, you have API endpoints. You need some advanced logic. You write a PL/PGSQL function. That's it.
So do you think you were as productive as them because of the technology?
Yes, technology,
Okay.
and the server-side programming. 25% of my time replaced 3 small team of 3 engineers of Ruby developers. Replaced fully, and I had tests, I had pipelines, everything. But unfortunately, then actually my friends came and they are Python developers, and they decided to replace it. We had discussions well, it's good. They said, oh, okay, but we don't know PL/PGSQL, we need to learn.
Yeah.
But with Python, we will create. So they replaced it, and it was, in terms of time, it's less productive. I mean, again, step back, but they brought much more on table, like machine learning and so on.
Do you mean they replaced the Postgres side? Oh, okay.
With Django. This is an interesting project. They started for Ruby on Rails. Then sometime, a couple of years, I supported them with Postgres and some PL/PGSQL coding. Then they had a lot of needs in terms of Python, and they decided to continue writing Python writing API in using Django and there. So
I thought you might have meant PL Python. But no, definitely
we discussed this opportunity exactly.
Yeah.
They could do that, but I don't know. This is like decision, like what you learn, what you know, and so on. Of course, if you need to scale, this is a little bit more difficult to scale because PL/PGSQL you need to learn. It's like other language, modified other language, very old and outdated. It has some if loops and if and some not super convenient approach to work with exceptions, errors, to catch them. But it's possible. It's quite. It feels like Pascal a little bit, right? But many things are possible there. But main benefit is that you're sitting there. You don't have round trip time.
Yeah.
You can be very efficient, but you need to understand how data flow with database is organized, and you need to understand how to troubleshoot slow plans, how to use explain command, how to optimize queries. You need to understand that, and you also need good environment where you can try many things and feel it. I mean, you need to production environment. I had it already, the database lab. So no, at that time I didn't have, but now I have it, and it's easy, right? You have same size development environment, so you can quickly see performance of what you wrote, of your trigger, of your function, and it's good.
This is so this is great. We've covered. You've touched on performance there, and I think that's if you look at the normal pros and cons list, that's one that people that are on the side of stored procedures they often bring up as if you're trying to get. If you're trying to avoid those round trip times, if you're trying to do some logic on your data that's in the database, doing it database side saves you a lot of effort, or can save a lot of effort there. So that's normally cited. That's probably one of the most compelling reasons for doing it.
Well, I would put on first place this logic that only database can guarantee that your like guard code, checking consistency, data clearness, and so on, it won't be bypassed by anyone. This is, for me, it's number one. This is obvious. Well, if you can put some proxy and guarantee that all people and applications will go through it, and you code some logic there, it's okay. But usually it's not so. So this is number one for me. Second, yes, performance and route time. We all know this extreme example when some Ruby or Python developer pulls whole data to application side and then processes it, right? Maybe in loop, updating row one by another. This let's pull it and then analyze it. This is very bad approach. Database can do it much more efficiently because it has indexes and for all another example, R code, which has some how to say analogs for group by, for joins, and so on in memory only. So
aggregations,
aggregation, grouping, joining. So they pull whole data in memory. At some point, this will be saturated. Memory will be saturated, but it's not efficient because they don't have indexes Postgres has already built, right? And algorithms and so on.
Databases are really, well, Postgres in particular, it has a really good query planner. It has, it's really designed to do that on large amounts of data. And doing it without having to send it backwards and forwards is always good. Even if it wasn't strictly better at those things, doing it without having to send that data across saves so much time normally in the modern world.
You still can have a problem if you, for example, use some cursor approach. Like if you, instead of updating all rows using one statement, you might okay, I will write PLPGSQL code, I will do some for loop, and in loop I will update each row. It also will be less efficient. So you can do mistakes using this approach as well, but at least you won't have network there, right?
Yeah.
I wanted to emphasize it's not only about round trip type, but also about capabilities you have. If you pull data to memory, you can do anything with it, right? But you cannot use indices which left on server side. You don't have them. So,
So we've covered like a couple of the things people often cite as really good reasons for pushing more and more, if not all of the logic that side. The downsides the criticisms I often hear are less good development.
Let's mention one more. Yeah. SQL in general is very, very it's very powerful for working with large volumes of data. So many things developed. You can write a few lines instead of hundreds of lines using regular language, and it's like okay, of course you want to ensure that it will be efficiently executed. That's why you need some understanding experience and good playground. But in general, it's much more brief. The code is brief, right? So if in PLPGSQL function inside it, you can use regular SQL combined with this PLPGSQL. It's like they are working together without any need, unless you use dynamic SQL, you can avoid using some like execute or query quotes and so on. You don't need them at all. So they are integrated already. And by the way, there's EdgeDB with their EdgeQL project, which try to reinvent SQL. It's another topic, but also maybe in future more convenient work will be done in using regular languages, JavaScript, for example. So I wanted just to say that code, much less code. So usually, somehow, much less code. You don't need to write loops and so on, open database connection, close database connection. No. Everything is automatic there.
So should we cover some of the downsides?
A lot of downsides. As I've said, I consider myself as not normal because normally people say we won't go this path. First of all, usually they mention that it's not convenient because there is no good developer tooling. IDE or debugger we usually mentioned. There is debugger actually.
But people aren't familiar. People are familiar with their existing, with backend framework debugging tools. So it's
I-
more familiarity and expertise, I think, when it comes to
Right.
using those things.
Right. I personally, I live in Tmux and VI. I'm not normal already, right? And I prefer avoiding graphical UI. I use it sometimes, but I like when my work is on some remote machine, so I'm not dependent on my laptop or anything. I can continue working in Tmux from anywhere, and also working in pairs if needed, and so on. But if we talk about like exactly IDE and integration, actually, maybe I don't know. Maybe there are some good examples for PLPGSQL which I just don't know. But we switch to PLPGSQL discussion only. But again, you can write using SQL, using PL Python, PL other languages Postgres has. But question is how you like debugger. Okay, in my personal opinion, you should have a lot of code. Complex, stored in multiple files to have a need in having debugger. There is a debugger for PLPGSQL. I never use it. I don't need it. Usually function, even if it's 100 lines of code, print lining is fine for me. Also raise debug. Raise debug is good.
What about tests? You mentioned testing. You mentioned when you had that project you were doing, you had tests for it.
Database lab.
What do you use for testing the procedures, making sure they don't break?
First of all, you should have enough data to test properly. So my approach is to have production size database, same number of rows or close to it. So you just spin off your thin clone using Database Lab and do anything there.
Do you use like pgtap or anything like for database size?
Usually I prefer using Skitch instead of Flyway, Lukebase or so. pgtap and Skitch, it's from David Wheeler, if I'm not mistaken, same author, right? So Skitch has verify, it has deploy, revert, and verify. You need to define 3 functions for each database migration you have. By the way, this is a good point. How you manage your function definitions, and how you store it, version control. Let's discuss it in a bit. So I usually try to have some logic in verify. PLPGSQL has assert function. It's very convenient. So you can write another, and you can also have anonymous do block in PLPG. It's also in PLPGSQL. So you do, and then some string. Usually people write $$ and then some PLPGSQL logic there, and there you can have assert. So you write anonymous do block inside verify function for Skitch, just to test something. For example, you have a function which did something. Okay, you executed it, then you ensure that the result is as expected. And if you don't have assert, for example, if in SQL context you need to verify it, okay, you can use divide by 0, or you can write a helper function which will raise warning, exception, warning, notice, or debug, anything you want. So you can have helper functions and call them in using regular SQL, and you can have some case command. If something like you check something using regular SQL, and write your helper function to report some error, for example, and it can be soft like warning or hard like hard stop, anything. So it's possible. You can have tests definitely, but the problem is that like debugger exists. I don't use it. I just don't feel it's needed. Never. I use a lot of asserts, and assert just like, this is not possible. Let's have assert here. And I use usually a lot of raise commands on various levels. And if you check my code, you can find raise debug in many places. So anytime when you're debugging something, you can like change client mean. Log mean client level. I always forgot. You can change in 2 places log level in client connection and in logs. So you can have messages printed to your output or in logs. It's quite convenient. And if you have raise debug, it won't be present anywhere by default, unless you say, okay, I'm in debugging mode. I change my level. in either or both places. There are two places, right? So, and you have those debugging messages immediately. Quite convenient.
Nice. But then on the flip side, I think people that are using Rails or Django or something, they have migrations built in already, and they don't have to worry about separate tooling for version control, source control, that kind of thing.
Right, but they also have. First of all, they can have functions, they can have triggers. They do it, and they also have quite advanced testing capabilities. So I think everything is doable. If you want to move some logic to database, it's doable.
And I think this is where I've landed. I think you can have a bit of both. It doesn't have to be, a holy war, one or the other. But yeah, I definitely see that more now.
Mm-hmm. But usually you have some discussions like, should we have business logic inside database or in application? This is a question like black and white question, right? So you need to choose one side, only one side.
Yeah. Did you see there was a post, I looked it up, and it's back in 2015 by Derek Sivers around his approach. He works by himself. He's got his own database, and it's a personal project, but he also sells his books. He's a very popular author, and he runs everything himself. And he wrote a post very, very strongly in favor of putting everything database side. And he's moved his application. He's migrated between different application frameworks. And I think actually that's a final point that often gets brought up in the argument, even if it's not super relevant. Well, I don't know. I'd be interested in your opinion on how relevant it is. But ease of migration of application and ease of migration of database often come up as arguments. And people seem to argue against putting logic in the database because they seem to think a migration of the database is more likely than a migration of the application. But I don't know if that's necessarily true.
A few things here to discuss. First, if you discover these capabilities Postgres has, you're very happy. But then, for example, you've built quite complex, sophisticated structure of views, for example, like hierarchy of views, right? And then you need to change some column. You need to redefine them. It's good that they can be, redefinition can be done inside one transaction, so small interruption, like a fraction of second, and that's it. Everything is transactional, good. But it's not convenient at all. So even if, for example, you have select star from some table, some view, for example, for Postgres, and you need to redefine it, a new column created. You really need to recreate on each. So underlying table changed, you need to recreate view. It's there is some maintenance cost here. In code, it could be different, and it could survive. You don't need to change codes. Well, if you added some column, maybe you need to change code, but you can write it in a way that maybe you will not always need them. And also, so hierarchy of views can be tricky and a little bit painful in maintenance. This is first thing. Second thing is more important. Where do you store your functions, and how do you approach versioning? For example, sometimes we need two versions, both of them. It can be possible if we have a lot of application nodes. Some of them already upgraded, some not. So we need to allow them working with both versions, old and new. People do this. Some people do this. They just use schemas, and they have bunches of schemas. Right, and you can clean up old versions later. It's quite convenient, but sometimes people say Oracle also has packages. Postgres doesn't have packages. It's I already forgot everything about Oracle, so I cannot comment on this. But it feels like we are missing something. Definitely not my topic though. But I wanted to say, think about one function and we change it. There is create or replace, but it's limited because if signature of function changed, for example, new parameter appeared, Also, it can be overloading involved because you can have same function name but different functions, multiple ones with different number of parameters, right? But you cannot create or replace function if, for example, some parameter changed its type. You need to drop it and define once again. And also dependencies. It's like quite complex. But my big question here, the biggest question here is that consider, okay, signature hasn't changed, but body of function changed. How do you approach versioning here? Question is, if you have old function version, new function version, where do you store versions? Postgres is not good for this. Okay, if you have, if you use namespaces, a very strict approach, right? You use like version 1, version 2, and so on and so on. But inside each version, you also might have multiple subversions, like you developing, right? And you want to fix, like you want normal version control with branching, commits, like probably you put whole function body to Git, right?
So yeah, how else would you do it?
I do it also. And it's good that if I change one line, I see diff, it only one line changed. But what about our Sketch, Liquibase, Flyway, or Ruby Active Record migrations, database migrations, or Django migrations, and so on? They're not friendly with it. If I include that function, okay, I keep each function in separate file, for example. Good idea because we can have normal Git flow and like pull requests, merge requests, approval process, and so on, review. But if we just include it, for example, if we have migrations, we include it into each migration. And imagine if we want to replay several migrations, which version of function will be taken? It will be the latest, and it's not right. We need to include, like not just include, we need to include in a correlated way.
Yeah, I used to work, I feel like we should probably do a whole topic on database version control, but I used to work on this. Yeah.
I have something to say about it, but I have a talk next week on PGConf EU about database branching. It's exactly about this. So
yeah, let's definitely discuss that. But if you do things application side, this is easier. This is all handled already.
Yeah, you don't have this problem normally. So, but with database, you need to do something about it. For example, in many cases, I see people abandon the idea to have this very big chain sequence of database migrations and ability to replay them, because you cannot include files, right? If you include files, you need to include all version of files. So I had some code like related inclusion for Rails maybe, or for Sketch, I don't remember. But it's like you need to develop additionally. So there is a gap here. Well, and this is not convenient. This doesn't scale well, not convenient. So people, if you work in teams, you have issues with that. But finally, like to finalize with cons of Postgres programming, the biggest negative side is that at some point it doesn't scale because this code, if you so imagine you have clusters. Each cluster has a primary node with read-write capabilities. Other nodes are read-only. Many of your functions will be read-write, so you need to write something. And a number of cores on the primary node is very limited. It's the most how to say,
scarce.
Yeah. So it's most
it's like a bottleneck, right?
Right. It's very important resource. You have very limited resource. Only like, for example, 96 cores, but that's it. And to scale, you need either to split your database in parts, or to apply some sharding, or just to scale vertically better CPU. So with more cores, but people, so if they don't realize it in the very beginning, if putting a lot of logic inside database leads to some saturation on CPU or on disk also very, very important resource here. We have only one limit for disk I/O on primary node. We cannot do writes on standby nodes, right? Unlike application, because but usually like writes are usually are needed. Writes, we need to do writes anyway, even if we have logic on application code. But CPU spent for some calculations and so on. and especially not only for calculations, but especially for communication with external world. The moment when you see that you want to process you need to analyze some external web page, some crawling, scraper or something, or you even need to download some binary like file, for example, image, and you are doing logic inside database. This is the like many bells should
Go off.
sound.
Alarms should ring. Yeah.
Yeah.
So-
It should ring. Yes.
Yeah, it's a great point about scaling up versus scaling out. It's easier to horizontally scale on the application side. While we're on the last topics, I wondered if you wanted to bring up sub-transaction, like the idea of
No.
sub-transaction.
Let's finish
Oh,
this.
okay.
Let me finish. Because I was in this, like, I replaced, as I said, teams of
Yeah.
whole small teams of Ruby developers, for example. And I did it twice, at least. I used this approach in many places of my own projects with Postgres, several also projects. I loved it. I advertised it also a lot. But the moment I started to write some curl logic in PL Python, or also I discovered PL/SH from Peter
Don't know
Eisendrath.
it.
It should be a very experimental thing. Don't do it on production. So you can write shell code, a bash code actually,
Oh, wow.
and have it in Postgres. So I had some logic with curl as well and bash inside Postgres to download and put some images somewhere. I also had some parsers of external web pages. You know the problem of an idle transaction, right? When application started to work with database, open transaction, then went to work with some external APIs. And for database, it means some delay, and we sit in transaction not doing anything inside database. Like if you start working with external things from Postgres, this comes to you very quickly. For example, I also had work with Stripe. Quite convenient. So charge somebody right inside Postgres. Stripe has very great, like one of the best APIs and documentation. I also sent some pings to Slack. When, for example, user registers, immediately sends ping to Slack using trigger synchronously. So it's not good. It's not good because you quickly understand that your CPU on your primary node does a lot of things it shouldn't do. And I see, as I mentioned Supabase, right? I mentioned Supabase, and I see they have already some signs they do go this path. They are growing like a rocket. A lot of users. I consider them as maybe the best team who can productize Postgres and Postgres extensions today. But I see PL SQL HTTP, for example, extension they have.
Yeah, they let you enable it, right? In
Right.
In their extensions. Yeah.
Some signs that this like wall is there for some projects. Don't do this inside primary if you want growth. Do it only as experimental, as prototyping, as like quick prototyping. That's it. Don't do this. I did it. I understood it. I did it, but just exactly for the speed of development. It's great, super fast.
Yeah.
But also secret management there. You need for example, if you need to work with Stripe, where do you keep your secrets? As GUC variables? I mean, Postgres variables, probably not safe, right? Yeah, anybody can select current setting or show. That's it. No, not good. Also.
Right. So, was there anything?
Oh, actually, you can. I remember I kept secrets in a table, and with permissions, nobody can.
You can.
Yeah, there is some approach.
Even Supabase are big fans. They big fans of row-level security as well as obviously permission-based.
Right.
So,
again, I'm not normal. I'm a big fan of this approach, but downsides are obvious, and everyone should understand them before going this path.
Exactly, and it age-old answer. It depends, right?
Decades of discussion.
Probably should have got that in up front. Last couple of things I wanted to mention that I forgot to while you were talking about them. On the query plan front, it can be really helpful. This using functions, nested functions, it can be really important to enable. Well, if you're using auto explain as a log nested statements parameter, and putting that to true can be really helpful for debugging or for performance debugging. And then on the SQL Server side, like on the other, the tools are a bit further ahead on this. So there was a project called SQL Server Data Tools, and Redgate, the company I worked at for many years, had lots of tools around letting you version control and test database side, which I haven't seen equivalents of in terms of the whole framework or the tooling on the Postgres side.
The biggest concern for their tools, I think Redgate has it. I mean regular version control tools, they all rely on Git. Git is not friendly with the big data volumes at all. It just says don't do this, and so we only talk about schema and DML comments. That's it. We cannot have data version, but we need it also.
Well, so they do have some. So both of those two do have some. When data is schema, so like lookup tables and things, you can version control that. But yeah, of course, in terms of CI/CD or testing performance, you do, yeah. If that's what you're talking about.
Or regular testing, you need data for testing. If you have only like few rows in a table, you cannot test properly. Search doesn't work, doesn't return anything, and so on. So it's also a problem.
Yeah.
But it's different problem, different topic at all. Like completely different.
Definitely, we should cover that one.
Sure. Okay, awesome. So we roughly discussed the big three pros and big three cons, roughly, right? So I still a big fan of this approach. I know majority people are not trying to avoid it, but still, like nothing changed. The pros are still here. So, and interesting to observe further how usage of Postgres side programming will change with projects like Supabase. Because users already use views and some logic and so on. Yeah.
And triggers are really common. A lot of use cases for triggers.
And Hasura as well.
Nice one.
Yeah. Mm-hmm.
Yeah. So. Well, thank you, everybody. Thanks for listening. Let us know what you think. Send us your requests as usual. We really appreciate it.
Yeah. Thank you, everyone. And share.
Oh yeah. Nice one.
Links.
Take care.
Share links. Thank you. Bye.
Bye-bye.